You know, AI is so often sold to us as this magical, weightless intelligence. We picture it as just software, humming along quietly somewhere up in the cloud, totally detached from our physical reality. But today, we're going to absolutely shatter that illusion. We're going to dive into the massive, very earthbound reality of artificial intelligence.
Because here's the big question we really need to be asking ourselves. What does AI actually demand from our planet? Seriously, every single time you type out a new prompt, ask for a snippet of code, or generate a cool AI image, you're kicking off a chain reaction in a very real, very physical system. And the resources that process requires? Well, they might really surprise you.
So, for a long time now, the public debate around AI has pretty much just been an argument about electricity. And hey, rightfully so. Bigger models and denser chips are putting an enormous strain on our power grids. But those exact same massive data centers demand something much quieter, intensely local, and incredibly politically sensitive. They demand water.
To understand how this all works, here's a quick roadmap for this explainer. First, we'll unpack the hidden cost of AI, then we'll break down exactly why computers drink water, look at the scale of the trillion-liter problem, explore why location matters most, and finally, look at the push for transparency.
All right, let's jump right into Section 1, the hidden cost of AI beyond the grid.
The truth is, the cloud is heavy, really heavy. Every answer you get from an AI is resting on top of a massive physical stack. It relies on millions of chips, gigantic concrete buildings, electrical substations, miles of transmission lines, and, absolutely crucially, massive water infrastructure. It's so important for us to realize that this technology is scaling up so fast that ordinary, local, everyday resources are now a direct, physical part of the global computing stack.
Which brings us to Section 2, why computers drink water, the mechanics of heat.
A data center, when you really get down to it, is basically just a giant heat management problem. It works like this. First, servers convert electricity into computation. Simple enough, right? Second, all of that dense, non-stop server activity generates a staggering amount of heat. Literally, if you don't remove that heat instantly, the equipment just melts down and fails. So, step 3, water is pumped in to absorb all that heat, and finally, that heated water is dealt with by evaporating it right into the outside air through massive cooling towers. The big catch with this cooling method is that the water physically leaves the local system. It doesn't just loop around forever. Once it evaporates, it's gone from that area.
And get this. The water footprint doesn't even stop at the data center's fence. The power grid keeping all those servers running is incredibly thirsty too. This is especially true when that electricity comes from thermal power plants, which burn fuel and use massive amounts of water for their own steam cycles and cooling. So you've got the data center chugging water locally and the power plant chugging water miles away just to feed it the electricity it needs.
Let's look at the sheer scale of this in Section 3. The trillion-liter problem, scaling the load.
Think back to 2021, way before this current massive AI boom even really took off. A study published in NPJ Clean Water by a researcher named David Mighton revealed a pretty mind-blowing statistic. Even back then, U.S. data centers were already consuming roughly 1.7 billion liters of water every single day. To put that into perspective, that works out to over 600 billion liters a year. And remember, that was just an early estimate when less than a third of these operators were even bothering to measure their water use.
Well, since then, that number has just absolutely exploded. Driven by the mad dash to expand AI capabilities, estimates cited in recent investor reports show that by 2025, North American data centers were on track to consume nearly 1 trillion liters of water a year. Just 1 trillion liters. So no, the AI boom didn't create the data center water problem out of thin air, but it has absolutely violently accelerated it.
And like we talked about, this water demand is tied directly at the hip to the power grid. According to a 2025 report from the International Energy Agency, global data centers gobbled up about 415 terawatt-hours of electricity in 2024. But look at their projection for 2030. They expect that number to more than double, with AI being the main culprit. Why does this matter for our water supply? Because electricity demand and water demand are a package deal. More computation means more heat. More heat requires more cooling. And more cooling inevitably means more water.
Now, let's talk about where this is all happening in Section 4, why location matters most, the local impact.
Here is a totally crucial point. 1 million liters of water doesn't mean the exact same thing everywhere. Looking at national statistics can actually be super misleading. If a company builds a data center in a really wet region that has plenty of spare municipal capacity and good wastewater recycling, well, it might just be a totally manageable burden. But if you drop that exact same data center down in a dry region or in a town already struggling with strained aquifers and aging pipes, that identical water demand is going to instantly trigger massive public disputes. These companies tend to cluster their facilities wherever there's cheap land and big tax incentives. And what that means is the impacts are felt intensely at the local level way before they ever register as a national crisis.
There's this quote from one researcher that just hits the nail on the head. They said, communities do not experience the cloud as an abstraction. And wow, is that true? Picture a summer heat wave. Local cooling demands are spiking, households are blasting their ACs, using more water, more power, and suddenly a mid-sized data center down the road becomes this massive, highly visible strain on the local utility. These towns aren't feeling some floaty, invisible cloud. They are feeling a massive, hungry industrial project demanding their power, taking up their pipes, and often operating in absolute secrecy.
Now, to be fair, tech companies are very aware of the optics here, and they aren't just sitting on their hands. They're testing out plenty of alternative cooling methods. Some operators are switching over to using reclaimed wastewater, so they aren't tapping into the local drinking supply. Others are specifically building in much cooler climates, so they can just open the vents and rely heavily on the outside air. And we're also seeing a big push toward closed-loop liquid cooling systems. These are pretty cool because they just recirculate the same water over and over, rather than continuously evaporating it up into the sky.
But, and this is a big but, all of these clever engineering solutions run straight into a brutal economic hurdle known as the rebound problem. This happens when every individual unit, like, say, a single server or one cooling loop, gets vastly more efficient, but the total system is expanding so incredibly fast that the overall consumption still goes up anyway. A closed-loop system is fantastic, right? But if a company has to build 10 times as many data centers just to keep up with the crazy demand for AI, their total water footprint is still going to skyrocket.
Which leads us to our final section, Section 5, the push for transparency, uncovering the data. So why is this so hard for communities to manage? Well, mostly because the numbers just aren't transparent. Big tech companies absolutely love putting out these glossy global sustainability reports. But what they actually do in those reports is hide their individual site-level water usage behind massive company-wide totals or really vague efficiency metrics. Think about it. If you live in a town where a new data center is breaking ground, a broad global sustainability claim tells you literally nothing about how much water that specific building is going to suck out of your local reservoir. And that lack of clarity is exactly why major investors and local communities are now putting serious pressure on tech giants to provide detailed, site-by-site disclosure. Thanks so much for joining me for this explainer today. I really hope it leaves you looking at the digital world a little differently, keeping its true physical weight in mind. Because at the end of the day, as AI continues to expand and asks our local towns to give up a share of their most vital resource, we all have to ask this one lingering question. How much water is this actually going to use, and exactly whose supply is it coming from?